Hello, my name is Vincent Rubino, and I am here today to talk to you about EEGoVid, an EEG-based interest-level video recommendation engine. EEGoVid is the result of a semester-long project by team members Mohammed El Rafai, myself, Vincent Rubino, Jingwen Ji, and Shi Zhang. We completed this project as part of the Big Data Analytics class in the fall semester 2014 at Columbia University. So first, I will give you a brief overview of our project. Then I will go on to discuss NeuroMatters, a tech startup that we collaborated with for data and advice in the space. Then I will discuss the motivations for our project and the tools we used for our ultimate system architecture. Then I will move on to briefly discuss performance of the system, and then to show our web interface and some examples of the data we have analyzed. Finally, I will briefly discuss our plans for the future. So what is EEGoVid, and where does it fit into the big data picture? Well, wouldn't it be great if you could know what every viewer of your video thinks of your work without having to ask them? Wouldn't it also be great if you could know why you like a particular video, even though you can't quite put your finger on it? Well, the information necessary to answer these questions was locked up inside your brain, until now. So we're going to try to extract that information and use it. EEGoVid uses EEG signals from the brain to determine interest in media such as videos. It then uses big data analytics and image processing techniques to find similar videos based on your mind's automatic assessment of a scene. It uses both the recommender engine as well as feature recognition, and we plan to tie the two together in the future, but for now they're separate features of our software. So where did we start? We didn't have the means of acquiring any data, so that's where NeuroMatters came in. NeuroMatters is a New York-based technology startup that develops technology for generating and analyzing an interest level of a group of participants who have watched a video. They acquire this interest level by correlating the EEG signals to time points of a video. They were kind enough to lend us their raw data. The raw data was processed, and we received it after the interest level calculation was made, so that we could try to find a novel meaning among the video information. So what did we do? Well, in collaboration with NeuroMatters, we used techniques that we learned in the Big Data Analytics class, particularly the recommender engine and feature recognition, to implement an interest-based video recommendation engine. So, NeuroMatters data corresponds to 65 videos of commercials from the 2013 Super Bowl. NeuroMatters correlated the interest levels from a population of roughly 30 individuals. We did not have access to the individual interest levels, but we designed our system in order to accept such data in the future when it becomes available. Some of our goals were as follows. We wanted to analyze the estimated captured interest levels in the video frames and correlate these interest levels with the objects in the video. We also wanted to capture keyframes and video objects that correspond to the interest levels. Then we wanted to invoke some image repository, such as ImageNet, or what we later learned would be some other type of image recognition capability repository, such as MeshApe. And then we would extract features from an image, and then recommend back to the user some other video based on the extracted features. So here you can see a brief overview of our system. On the left there are users whose EEG signals are being inputted. In the middle we have the EEG-based interest levels, which correlate to some interest in the video. Here, high, low, and medium correspond to 1, 2, and 3. We also went down to 4 and 5 as well to make our interest level more meaningful. Then we would extract video frames based on these interest levels. We would run some feature extraction and then ultimately perform a recommendation. Libraries that relate to feature extraction and also to big data analytics. The overarching tool we used was Mahout, which we picked because of its recommender, and we used recommenders of various types, The analysis of those types follows this report and is in the final few slides. We used OpenCV, an open source computer vision framework and library, in order to do image extraction from the videos and for some pre-processing techniques. We used the MashApe CamFind API in exchange for the ImageNet API because it seemed like the MashApe CamFind API gave a much better feature extraction and text-based result than any other API we had used. We didn't use Hadoop, HBase, or Hive yet, but we've carved them out for the future, and it should be fairly straightforward to implement them based on the frameworks we've used. For visualization, we used D3 in JavaScript from d3js.org. That produced some cool visualizations of our dataset. Finally, we used MATLAB for some of the processing of Neuromatter's data. So now let's talk about the data. The dataset provided by Neuromatters included 32 individuals viewing 64 videos. The videos varied in length from 15 seconds to 1 minute. The dataset included time-resolved overall level of interest for each commercial. Our software, EEGoVid, integrates this dataset with feature extraction and image searching provided by MashApe and YouTube. We originally planned on using ImageNet and WordNet, but their capabilities were not a clean fit. So this next slide includes our overall system architecture. This diagram is a few weeks old and might not capture the exact system as it will be released. For example, we are still not working with Hadoop, and we are also not working with Neo4j, even though they are represented in this figure. So what about the data itself? This is an example of an interest level generated by Neuromatters. As you can see, it's time resolved, and it has an engagement level on the left side, which shows the engagement of a user. In this particular example, you can see the peaks are roughly at about 0.2. So for this piece of data, we would have extracted the image frame from around the peaks at 45 seconds and 9 seconds. After we picked the highest point, we extracted several frames from that time period in the video. Here you can see MashApe extracting features from a video. In this case, there's a blue Muppet with a red box drawn around him. One of the other considerations we gave was whether to extract the frame from the exact high point or some time leading up to it, since the interest could have been generated by something prior to the peak. Next, I want to briefly touch on our performance metrics. As you can see, we split our data set, even though it was relatively small, into training and evaluation data and tested our methodologies. The overall answer was that everything worked pretty well, except for, as you can see in this figure, Euclidean distance. Extraction. Different algorithms were better when compared to using ImageNet. In particular, the MashApe algorithm seemed to be the best fit, but it still isn't perfect, and there's lots of information we still could extract about things leading up to the point of highest engagement in the scene. Finally, users can receive recommendations for movies that they will feel are truly similar, even without having to click or tap on anything. So what was our next step? Well, we took the code written in Java and we put it on the internet in a web app. We used the Play framework for rapid Java development, and we deployed our website to Heroku, which makes rapid development fairly straightforward, especially with Play and Java. Heroku, in particular, will be great for the future, since they have a new and fairly simple integration with Hadoop. So now I'm going to take you up to an example of our homepage. So here is our web page at eegovid.com. Here I have a local version of it running, and then I also have the final production version of it running at EEGoVid.com. We're still cleaning up the UI, but our basic functionality is in place. So the Notifications tab on the left is a Mahout user recommender. It takes in a CSV file behind the scenes, processes it, and then the results of the recommendation are displayed on the screen in this table. The recommendation is then visualized using D3JS on the right. Weights and connections are seen between the videos in the thickness of the lines, and the videos and users are represented by the numbers in these circles. Once again, this is just for testing purposes, and hopefully our data sets will grow. As you can see, we do have a few data sets here that are somewhat larger and a couple that are smaller. But for the most part, this is a framework that will be valuable for the future. Then underneath we have a selection of the videos provided to us by NeuroMatters. So for example, we can see video number 1, which was titled Audi Big Game Commercial Dober Wawa. When we click on this video, it gives us some additional information. Here we see that the video has a cover image and then the extracted image. This is the image that was extracted from the point of highest engagement in the video. If we click on it, we can get a bigger picture. And then you could see that the Mash Ape API gave us a result of women's black jacket. So if we want to suggest a new video, it will give us a YouTube link and it will take us to YouTube for our suggested video hits. Now, this framework actually works within our website, and if the interest level is not yet calculated, we can calculate it here in real time by clicking this button, although it does take up to 30 seconds. Finally, we also have available the Dropbox of videos that we analyzed, and here is a clip from the Dober Wawa video. And right about here was the point where the highest engagement was measured. So this brings us to the future. We are still working on integrating bigger data sets into our framework, and we're also going to see what the real interest and engagement level is when compared to an extracted frame. What I mean by that is whether or not it's the highest point or some point leading up to the point of highest engagement, or possibly related to the highest area under the curve, or slope, or some combination of those things. Finally, we're going to look to tie together the feature extraction and the Mahout recommender engine by extracting features for every time point, connecting the words extracted from those features, and then running the recommendation engine based on the common terms. And thank you all for listening. If you have any questions, you can email us at these email addresses. And again, thanks to NeuroMatters for all of the help and the guidance throughout this semester.